Good evening, everyone, and welcome to another live webcast from Capture. Today with me in the studio we have a special guest from very far away, another part of Gothenburg actually, or a neighbor part, Michael Karlsson. Welcome very much.
Thank you. Nice to be here.
Great. So Michael, you work for a company called LumenRadio.
Yes.
In Gothenburg, and it's fair to say you are heavily involved in DMX stuff, I believe.
Yes, I would say so. We're manufacturing of wireless DMX equipment. So yeah, DMX is a very centric part of what we do. Yeah.
Great, because the topic of today is DMX. Of course, DMX is something that it's difficult to work in this industry without getting involved into DMX in one way or another. So we're going to try and cover, well, a lot of DMX related topics today. When we started preparing for the webcast and we started making a list of things we could talk about, initially I was a little bit worried that it could be a bit on the thin side maybe, but we found so many great things to talk about that I'm more worried about which bits we're going to cut out.
Yeah, the more you dig into it, the more you realize there is to talk about.
Yes, yes, definitely. So, and we do encourage everyone watching to, if you have any questions, if we say anything weird, if there's something you want to know more about, write it. I've got an eye on the chat here. Hans is already sending his regard to us. So please don't hesitate to write your questions. I might save something for slightly later if we're in the middle of another topic, but we'll try and cover everything. So let's start with the obvious question. What is DMX?
Yeah. So simply put, DMX is a standardized way of transporting control data from a lighting console to the actual luminaire that you want to control. Basically, telling the luminaire the amount of light output or the pan and tilt setting at a particular point in time. That's one way of putting it very simple.
And it is mostly limited to lighting, isn't it?
Yes. There are occasions where people use it for other things, but primarily it's designed for controlling luminaires. And there are some things that you just shouldn't use it for.
Like pyro.
Like pyro, for instance.
So don't do that at home, kids. Don't use DMX for pyro. That's a bad thing. Yeah. So who decides how this works then? I mean, obviously there are a lot of brands out there, and people might do things differently. So
yeah. So one of the points of having a standard is actually to get people to do it in the same way, so that you encourage interoperability between equipment from different manufacturers. So DMX is a standard. It's an ANSI standard, so an American national standard. It's developed by an organization called ESTA in the United States, which is basically a trade organization where manufacturers in the industry and also other special interest groups like end users, etc., are encouraged to participate and basically driving the development of the standards forward to meet the demands of the future.
Yeah, and I mean, in terms of what is included in the standard, we're talking about electrics mainly.
Yeah,
right?
When it comes to the DMX standard, you basically have everything from like the signal levels on the electrical side, the type of cabling that you're supposed to use, a DMX cable, yep. But also the data format of the actual data going over the cable. So you have both basically on the bit level, how's a particular data bit transmitted on the cable, and also how is all the bit composing up to something that the luminaire can make sense of.
Yeah, so I think it's worth pointing out that the data that goes over the cable, it's a long series of dimmer levels, you could say, dimmer or pan levels or different control signals. So they come in blocks of 512 levels.
Yeah.
Which is why it's called DMX
512.
Exactly. But there's a 513th little thing as well?
Yes, there is one part of the data stream that we call the start code, which is basically to be able to send different types of data over the same cable. So there's basically a part of the packet that comes first that tells everyone who's listening that this is a DMX data stream that arrives, so that you know that you should interpret it as a dimmer level, for instance.
As opposed to, because there are some other things you could send through a DMX cable that are essentially, I think they're manufacturer specific, more or less.
Yeah, you have manufacturer specific stuff. You have test packets to basically test your infrastructure. And you also have something that's called RDM.
Indeed.
RDM is basically an addition to DMX, while DMX is designed to control the luminaire. RDM, which is short for remote device management, which is basically designed for configuring and monitoring of DMX controlled equipment.
So all this can go through that same DMX cable, and so it's a rather versatile, in a sense, standard.
Yeah.
But of course, I'd say maybe the major limitation is that you can only run one DMX universe per cable. So if you have a big show with hundreds of universes,
there will be a lot of cables. And there is a lot of cables.
Yeah.
But when using that, like that large shows where you have maybe 200 universes of DMX, it's more common, I would say, to use, like, package that DMX data going over some other type of electrical medium.
Like Ethernet?
Like Ethernet and fibers and so on, just to be able to get more data over the same amount or just a fewer cables.
So a few Ethernet protocols worth mentioning would be ArtNet,
streaming ACN, so whereof streaming ACN is also an standard from ESTA, the organization, the same organization developing DMX and RDM standards, while ArtNet is developed by a company in the UK called Artistic License, who has chosen to release the protocol free for everyone to use.
I think, and one of the main guys behind it, Wayne Howell, was also awarded an award earlier this year.
Yeah, earlier this year.
For bringing this protocol to the industry. So obviously, if you're using Capture, our software, then since it's a computer software, you need to get the control signals into the computer. And in our case, it would be more common that it would be coming over the Ethernet with ArtNet or streaming ACN.
Yeah, that's probably the most common ones. There, I guess even for Capture, you have the option to take DMX in through other interfaces as well.
Yeah, we tend to recommend people to use conversion equipment that would convert from DMX cable to something Ethernet based, which means connecting the Capture computer to your networking equipment and getting the DMX over ArtNet or streaming ACN.
Yeah.
Which leads me to questions about network equipment, because there is a lot of different types.
There is a lot of different types, yeah. And there's both types of equipment that you typically run across, and there's other types of equipment that might not be as common, but people often, from my experience, have a hard time telling them apart. For instance, when it comes to Ethernet equipment, you have Ethernet switches versus Ethernet hubs, where basically the main difference is in a hub, everything that goes in on one port comes out of all of the other ports, while the switch is slightly more intelligent and can make intelligent decisions on how to forward traffic.
I think hubs are becoming less common. I don't know if I've seen hubs.
Yeah, lately, the last decade or so, I think they're starting to get quite hard to actually get your hands on.
We're that old then.
Yeah, yeah, starting to get old. Yeah, but also when it comes to other types of equipment. You will have like wireless equipment like Wi-Fi, access point, routers, and so on. So there's a lot of different types of equipment to keep apart and use the right one where they should be used.
I mean, there are on a budget level, I'd say essentially there's the common off-the-shelf product that you could go and buy at Saturn or MediaMarkt or whatever your hardware store is, where you'll find a switch for around 100 euros or even cheaper.
Yeah.
And then there's the kind of network equipment where you don't actually even understand what it does unless you have education and training.
Yeah, it's we typically recommend basically if you're doing small types of shows, like a few universes or so, we actually tend to recommend going for the cheap equipment because they're not trying to do things too smart. But if you're going to do a show like Eurovision Song Contest or something, you will not get away with that type of equipment. But then you probably also have someone on the show that actually knows networking to that level.
So is it fair to say that if you are doing a large show and you have complex needs, then probably if you don't understand that type of equipment, you should
probably have someone on the show. Yeah. Like call a friend.
Exactly. Yeah. And if you're not, then stick to the simpler equipment.
Yeah. It's like I know many venues that run like up to 10 universes or so over Ethernet and do that just fine with like the maybe not the 100 euros switches, but at least the 300 euro switches.
So how much DMX could you run over Ethernet then? I mean, so technically speaking, the DMX cable is 250
kilobits. So that's somewhere around what your ADSL line did like 10 to 15 years ago.
Yeah. And so if you're on a 100 megabit network, then you've got about 400 of these cables.
More or less, you have some overhead onto that as well.
Of course, yeah. And the synchronization, because you want probably all the DMX to arrive at the same time.
Yeah.
So if you're running a video wall, you want each tile to update
at the same time. And obviously, when you do this type of cabling, if you have 40 of these or 400 of these, maybe, then you have the option to actually send the data synchronized, so they can go, all the universes could arrive in parallel and then arrive at the same time. When you package it over Ethernet, like you still have a single cable where all the data will pass through, meaning that the data will arrive in sequence instead of in parallel. Yeah. And then you could start to run into synchronization issues. And that's one of the areas where we have standardization progress going on now with addressing the type of synchronization issues.
With streaming ACN,
With streaming ACN and a large number of universes.
So on the topic of streaming ACN, one thing I think is worth mentioning is that streaming ACN is built on something called multicast.
Yes.
Which means you don't send the data to everyone on the network, you send it where it's needed. But that also means that, you're supposed to have a network when you use that protocol. So
yeah,
one issue a lot of our users have seen is when you're in your garage or wherever you are, where you have just your laptop and your console, and you run a crossover cable, that you can run into issues with the more advanced protocols.
Yeah.
Because they expect you to have a network.
Yeah, and actually sometimes it boils down to just as simple as modern network equipment, or like your computers and so on, they often have something built into their network interface that is called auto crossover, which basically means that when going back like 10 to 15 years ago, you had to connect a certain type of cable from your computer to a switch. If you wanted to connect your computer to another computer, you needed to have another special cable.
Exactly.
And since that basically just created a shitload of problems, to put it least, because people always had the wrong type of cables laying around.
And you thought they were color-coded until you discovered that they were just colored for fancy, and
Yeah.
that wasn't helpful anymore.
So manufacturers started to going over to basically having the computers detecting the polarity of the cable and being able to switch over from one on the other. And you can run into problems when connecting two computers together that they both trying to switch over, and they basically end up trying to switch over all the time. So if you don't get things working, try to put a switch in between.
Have a switch with you, even if it seems useless. There are good reasons to have it in there for good measure. So we did touch some wireless transports as well, like Wi-Fi.
Yep.
So what about running ArcNet or streaming ACN over Wi-Fi then? That sounds like a convenient solution.
Yeah, I might be slightly biased on the topic, but in general, what we say is don't. Like
That's clear.
Yeah, it's a very simple recommendation. Now, Wi-Fi is designed for you reading your emails, where you don't really care about if all your emails arrive at the same time or if they arrive one after another.
Anytime I open my email client, they are already there. Anyway.
They're already there anyway. Yeah, but when running DMX, you kind of want the data to arrive at a certain pace. Yeah. First of all, when it comes to Wi-Fi, most access points have mechanisms for trying to avoid transmitting on the air. So they buffering data, and then they send a lot of data at the same time, meaning basically that you could get the last half second of DMX arriving at the same time to the luminaires, which it will yield in a very like non-smooth fades and so on. Yeah. But then you delays, stepping and so on, yeah. Then you also obviously have the topic of reliability. Like there might be one thing if you're running something at home for your Christmas lights, but doing something professionally, you have to have something that you can rely on. And I don't know about you, but how often do you have a problem with your Wi-Fi at home?
Well, next question, please. Yeah, we have a comment here from a viewer that it's better to always use a switch to manage collisions properly.
Yes, like when you have just two pieces of equipment talking to each other, on an Ethernet cable you have what we call, you have two pairs of cabling. The data is transmitted over a pair of conductors, and you have one going basically in each direction. So when it comes to Ethernet, you can have data flowing in both directions at the same time, something that we call full duplex.
But in the air, obviously.
On the air, obviously, you have just one piece of equipment that can get access to the medium at the same time. When running multiple pieces of equipment, first of all, you will obviously need something to connect all the cables together, which today typically is a switch. And that also handles, as they point out, collision handling between and prioritizing between what ports are allowed to talk to each other.
So obviously, if you step up from the Wi-Fi equipment to the professional gear that you work with and manufacture, you have your own methods of dealing with these problems, obviously. Yeah.
So what we're focusing on is just like that reliability and the short latency of data, because obviously from the time where you push a button on your console, you don't want it like a variable delay or something until something happens out there.
Your rock and roll flashes will not seem timely.
Yeah, so that is actually a very big part of it, just getting data to a fixed latency or a known latency at least, which is predictable.
And obviously there will not be any collisions caused by someone jacking in that printer on the office network at the same time.
Yeah.
Because it's
just not the same network.
Yeah, it's a dedicated Yeah, it's like a virtual cable, more or less.
Yeah, that's basically how we put it. What we're trying to get people to think about it is basically a wireless cable.
Yeah, that's straightforward. All right, so what is, let's say, what would be the most common mistake or issue that you could find yourself in when working with professional wireless DMX? Are there any issues, or is it just smooth sailing?
Well, there's always issues, and most of the time it's because you don't know the limitations of the products. It could be, for instance, you walking into a large stadium where you have installed equipment and you have everything working just smoothly during the setup and so on. And then you have maybe 30,000 people in the audience walking in. Basically, you have put your transmitter and receivers in basically shoulder height of people, and all of a sudden you have a lot of basically water blocking the wireless signal path. So just as long as you know how to use the equipment, how to install it properly and so on, there's actually, you get quite far.
So in terms of, you mentioned you might get into a venue with other equipment as well, because I know there are some different manufacturers in the area of wireless DMX. How well do they play together?
Well, first of all, you have to know that from all of the wireless equipment that are out there on the professional grade, there's actually more or less, and many of the type equipment from different manufacturers, they're actually the same stuff under the hood. Basically, manufacturers buying technology from one of the major players in the wireless field. OEMing, where obviously we consider ourselves to be one of those players. Actually, a lot of that equipment will work together. Usually, it will say somewhere in the manual or on the specification page for the product what type of wireless technology they're using. Yeah. But connecting back to what we started out with, the standardization, today, unfortunately, there is no wireless standard within the industry for wireless DMX.
Do you think there is need for such, or?
I definitely believe that it would open up the market to a greater audience, so to say. So, yeah, I definitely believe there would be benefits of a wireless standard.
Would it create competition issues of any sort, seeing that you would then all be speaking the same language, so to speak? I mean, you wouldn't have language. Today, one might claim he has the better language than the others.
I would say it would depend on how you write the standard. Like even today, you have people preferring network equipment from a particular manufacturing, like from Cisco, or when looking in our own industry, you might prefer like Ethernet to DMX gateways from Artistic License or from Luminex or someone, just based on other aspects of it rather than the actual transport.
All right, fair enough, fair enough. So coming back again to we touched the standardization again, and please, everyone watching, if you have questions or if you want to follow up on something, then please write and comment. I'm keeping an eye here on the chat window. So coming back sort of to the standardization area, obviously as we've talked here, it's becoming clearer that there are pitfalls. You need to be using the right equipment. There is sensitivity in cabling, so on and so forth. There's a lot of technology going on here. Yeah,
it's a lot of technology going on. Luckily, most of it you can leave over to the actual manufacturers of the equipment. But there are a few things that you, as a user, also should be aware about. Like, for instance, you touched on the subject of cables. That is one of the things, that use the right cable for the right purpose. So how do I know I've got a good cable for the purpose? Well, there are good cable brands, and typically put, if you would call your local supplier, like any of the major supplier in your local country, ask them to get DMX cable, you will get a proper DMX cable. There is a lot of people actually using, for instance, microphone cables for DMX,
Right.
which might work in a small scale, but when scaling up and doing longer cable runs, you will most definitely run into problems.
So what happens if I have a bad cable then? So we talked about the right cable, but what would happen if I had the wrong type of cable?
Worst case, you probably could get a blackout. But more commonly, you would get glitches like flickering and so on, if you get it to work at all. Basically, what you get is sort of collisions on the cable, or actually what you get is the signal when it's traveling through the cable at the speed of light reaches like the transition from one type of cable into the other type of cable, where you have a mismatch between the two types of cables, and you get what we in the industry, or as a manufacturer, call like a signal reflection, the signal actually going back to the cable.
I guess you could think about it almost like, you know, when you hit with a flashlight into a puddle of water, some of the light will actually bounce back.
Yeah, some of the light goes into the water and some
into water, and it's different.
Yeah.
And that is the reason for termination as well, isn't it?
Yes, very much so. So when you reach the end of the cable, basically what you get is you have the signal coming through the cable at a really high speed, reaching just open air, which is basically you have what we call impedance. You have an infinite impedance, which is quite large difference from what's in the cable.
I think about it like driving off a cliff. Bad.
Yeah, it's typically bad.
You need to have something to stop you.
Yeah, most likely you won't survive, and it's the same here. Maybe you don't survive from, especially if you're doing pyro over DMX.
Don't do pyro over DMX. Like, just don't. Yeah. So buy your cable from a well-known source.
Yes.
If you're buying directly from China, don't.
Yeah, at least you have.
Unless you're an electrical engineer and you know how to verify.
Yeah, at least you need to be able to verify that you get what you're actually ordering. Yeah. And if you're asking that question, you probably don't have the knowledge to define that.
Yeah, exactly. So I'm going to take a few steps back here to address a comment we had on wireless DMX and how many universes wireless DMX will handle.
Well, it's very different. So that's one of the gotchas when it comes to wireless DMX, that depending on the installation and what other types of wireless equipment you have in the area, it will differ. So if you're doing a lot of wireless universes, you should do some proper planning of that. You might have venue Wi-Fi that you don't want to disturb. And basically you have a limited number of wireless frequencies, like the radio frequencies. There are just ever so many, which of just a small part are actually available for use without having really expensive licenses. And that's where all of us have to share the same space.
So if you're pushing the limits, then you need to check what else is in the venue.
Yeah.
And maybe even test it.
Yeah, testing is always a good thing, but I would say if you would ask some sort of generic rule of thumb, if you're doing up to, say, let's say 10 universes, and I think I speak for all of the major manufacturers of wireless DMX, is up to 10 universe you basically could just plug and play. After that, it would be different between different manufacturers and how to approach it. So you should basically ask the representative of your preferred brand of wireless DMX on how to approach it.
What the limitation is, yeah. So I kind of lost track where we are as we start jumping around a bit. There was one thing we wanted to mention as well, and we've talked about cabling and the importance of having the right cabling. But I've heard that some people run DMX on network cable as well, as in more or less.
As in actual DMX.
Putting the five pin connector on a UTP cable.
Yes.
A network cable.
Yeah. And actually, from an electrical perspective, UTP cable, as we call them, or unshielded twisted pair cable, which is the technical term, is actually better from a signal perspective than a traditional DMX cable,
so
which kind of is a bit odd.
So will the signal be happier, or how is it better?
Actually, to be a little bit technical, what you have inside of the cable, these pairs that we talked about earlier, these pairs are twisted like around each other, and the purpose of that is the electrical or the electromagnetical fields around us, from everything from ballasts and so on, that creates interference. Cell phones and so on. By twisting the cables, both of the cables in the pair will be subject to the same amount of electromagnetical interference. Yeah. So basically then, the tighter the cable is twisted, the more similar type of interference for the two conductors in the pair.
So it's more robust the more it twists.
Yeah, so the fact with the unshielded twisted pair network cable is that the pairs are more tightly twisted than in a network cable, or than in a DMX cable. Yeah. So that effect is actually greater than the shielding of a DMX cable.
So loosely twisted, and this is the network cable to my laptop. This is more tightly twisted.
Yes.
Yeah.
There is also one other benefit of that cable, is that you have two pairs. In this cable, you have one pair. So you can actually run two universes over the network cable if using
cheaper.
DMX. And it's a lot cheaper. Yeah. Obviously, sometimes the DMX cables could be much more robust.
Yeah. I mean, yeah.
The DMX cable most of the time is more touring friendly and so on, but if you do fixed installations, retail lighting, facade lightings and so on, the network cable, or the RJ45, as some people like to call them, could be a better choice.
But there are different types of network cable as well. We speak about Cat5, Cat6.
Yes.
And there's different shieldings.
Yeah.
I mean, we say network cable. Does it mean I could use any network cable, or should it be the more shielded version?
Actually, the effect of the twisted pairs is much greater than the shield. So you're most often fine with the unshielded ones, which is also more flexible and often cheaper.
Fair enough. So in this guy, there's only one twisted pair, but we have 5 pins here.
Yes.
So this sounds to be like what in Sweden we call vaska, which essentially means wasting. So we're wasting 2.
Yeah, it's because we don't like to be cheap.
Yeah, right. Yeah, we're a bit more luxurious here, so we can afford wasting 2
pins. Yes.
Right. So yeah, so don't be cheap and use 3-pin connectors.
Yeah. Joking aside, actually there was an idea from the start with having a 5-pin connector. We were talking about you having one pair of data conductors in the cable. We talked about RDM earlier. Early on, there was an idea of adding a second pair in the cable for the talkback from the fixtures. However, getting to that point, you realized everyone out there already had all the cables with just one pair, and the 5-pin connector stuck.
Yeah.
But on the other hand, it also makes it a lot easier for you to distinguish them from a microphone cable, which you shouldn't use.
Which you shouldn't use, yeah. We've been stressing that. So we have a question here, obviously jumping back a bit again. So if there was a standardization of wireless receivers, I guess that would imply also of transmitters, because it needs to be symmetric to some extent. That this would potentially benefit manufacturers and clients in terms of compatibility and...
Yeah, there's definitely benefits of having standards. Like, just look at your laptop, for instance. It would be quite not very useful for you if your Wi-Fi in your laptop weren't standardized so that you couldn't connect to any wireless access point or any hotspot, so to say.
This was, I remember way back in the day when I connected my computer with network cables, and there were things like IPX and different types of networking.
Yeah.
So there was a point in time where networking computers also wasn't as standardized as you might wish today, or for them anyway.
Yeah. One thing that we have to remember is the standards that we are using today in computer networks actually stretches back like 50 to 60 years from now when those standards were actually designed. So it's not really moving that fast as one would think.
And I know in the beginning of DMX that there was also quite a few years of compatibility issues.
Yeah.
Even though there was a standard, it didn't necessarily mean that everyone got it right.
Yeah, that's one thing. And also actually still today, you could get fixtures that you're seeing flickering for no apparent reason as soon as you switch on RDM, which is kind of not the way it was intended. And that is actually due to not being compliant to the DMX standard, which we talked about earlier with the start code. Many manufacturers in the past, it's much better today, but in the past many manufacturers just assumed that any data coming on the DMX cable would be DMX.
Because that would make sense.
Yeah. When you're starting to put RDM on the same cable, which obviously then has another start code, and some fixtures interpret that RDM commands as being DMX, and then you get the flickering.
Yeah. And actually, speaking of ArtNet, for instance, and I think even streaming ACN, you could send data with other start codes over ArtNet.
Over the same protocols, yeah.
Over ArtNet and streaming ACN as well. I haven't seen that used. I do know that in streaming ACN there are a few things like putting channel priorities.
Yes. For instance, ETC has support for something they call per channel priority. And then you might ask, what is priority for that sake? And basically, if you have multiple DMX sources for the same universe, you want to like take those sources, two sources of data, and decide what shall I do with it. Then you have something that is called merging, like merging those streams of data together.
Merging backup, fallback.
Yeah, for instance. So then you might have something that's called the priority, which basically means that as long as the higher priority data is there, that's what you should use. If that data goes away, you use the lower priority data. And with per slot priority, you can do that not only on the entire universe, but on a specific slot.
Segments.
Like, for instance, a specific dimmer channel in the universe.
I know Capture supports per channel priorities over ETCnet2, which is an earlier protocol that ETC used to use.
Yeah.
We haven't implemented it with streaming ACN, as far as I can remember.
Yeah.
But I know that streaming ACN, for instance, this is still work in progress. There are still changes made to the specification.
Yes, there is. And currently there's work being done on standardizing streaming ACN to run also over what's called IPv version 6 networks. You might have heard that people talking about the IP addresses in the world, so that we're running out of IP addresses. Yeah. That refers to the old version of Internet Protocol IP. It's called version 4. So
how do you think this will affect, I mean, obviously in a theater, you're not going to run out of IPv4 addresses.
Hopefully not.
That would be an awfully big theater. But would it be your opinion that because we will move to IPv6 on the internet, this will also affect how we work on smaller networks?
I think it will affect it, but to be fair, I don't see IPv or IP version 4 going anywhere anytime soon. We will still live it with at least the next coming 10 to 15 years, but we might starting to see equipment that support both versions.
Good point.
Then you might run into some interoperability issues. So in the standard, we're actually putting requirements on equipment that you have to support IP version 4, the old version, just for interoperability reasons.
I know with Capture we need to start supporting IPv6 because as computer users they are often more interested in getting out on the internet than doing stuff locally on the network. So we might reach a point where you might only have IPv6 configured in a network, especially if you're on a more mobile device like a tablet.
Yeah.
So I think it will, as you say, might not take over, but it will definitely affect.
Yeah, we will definitely start seeing more and more networks when we run both versions simultaneously.
Yeah. That scares me a bit with multicast stuff, and things can be tricky enough as they are. So we have another question here regarding, so we've spoken about IP addresses, but you can also run out of frequencies, I've heard.
Yes.
So what does the word look like in that department? Are we running out of frequencies?
Well, I would just put it very simply, I would say yes. So we, at LumenRadio, we like to say that we have to stop treating the frequencies like we did with oil in the 70s and 80s. We can't just pump and like there is no tomorrow. So you have to be smart about the frequency usage. You have to care about other wireless systems in the surroundings. Basically having methods for coexisting with other wireless networks. And simply put, if you start from a very low frequencies, at one point there is not radio frequencies anymore, and the same thing when going up in higher frequencies, at some point it starts to become other types of electromagnetic radiation like light and so on. So
light transported DMX.
Yeah, would be great with transporting the light control data over light, which is basically what we do in fibers.
True. So yeah, so if you're running DMX over fiber, you're using lighting to transport the control of the lighting.
Yeah, oh no, my brain hurts.
Yeah. So I think we are coming close to the end of our session. So if you guys have any more questions, make sure to fire them away pretty soon, sooner than later. So we've covered many topics here from cabling to radio frequencies, electrical characteristics, some networking as well. We had some notes here about IGMP snooping and more advanced multicast technology.
Yeah.
I would really encourage anyone who wants to understand more about networking to go buy a book maybe.
Yeah, there are several really good books about Ethernet networking. And if you're really into doing large shows, there might be a good idea to take some Cisco courses and so on, like they have certified network administrating courses. We will learn a lot about how to set up proper networking, even for lighting.
For us as capture manufacturers, it's can be a very big challenge to in a support situation to help our customers fix issues in networking, because in essence we need to know exactly what the network looks like, how everything is configured, and what everything is. So it's very difficult for us to assist our customers with networking issues.
Yeah, I don't know about your customers, but from our customers, we have so very wide range of knowledge at the customer side. We have customers that, without hesitating to say, know more about networking than we do. And we also have customers that barely knows what a network is. So that's a challenge for manufacturers, having to deal with that wide area or scope of knowledge.
Yeah. So we have a final question here, which will be the one upon we close today. From Martin Bell, would optical DMX be a thing of the future? That's an interesting question, I think.
With optical, I mean...
So I suppose rather than having an electrical cable, sending DMX, not as an Ethernet DMX, over an optical cable sounds pretty expensive to me, to be honest.
Could be expensive, but and could also be a little bit fragile. But on the other hand, we do run DMX over fibers today, often from like front of house to stage areas or so. So it's done to some extent today, but not as a standard on the actual cable level, but as standards on protocols running over networking through fibers.
Yeah, correct. Well, thanks everyone for watching today. Thank you for coming and joining us. It's been a pleasure.
Thanks for having me.
Thank you very much. And on that note, we will end, but we will be back with another live webcast in the beginning of December, when ETC will be joining us, and we will be taking a look at some advanced color mixing topics and visualization of color mixing. So make sure not to miss that, and thanks for watching us tonight. Goodbye.